So now that we've had a good look at Euler paths and Euler circuits, I'm going to give you some advice on how to determine whether you'll have an Euler path or an Euler circuit without necessarily trial and error and just seeing if you can make it work. So the first thing that we need to look at is even and odd vertices. So remember, vertice is the same thing as a node, and it's just the point on the graph. So we can identify whether it's an Euler path or circuit if we know how many even or odd nodes it has. So thinking about even and odd nodes, it's just like even and odd numbers. Think about how many what the degree is here. So if the degree is an even number, you have an even vertice or an even node. And the same if you have the degree is an odd number, you'll have an odd node. So it's important to be able to do that. And again, evens are things like 2, 4, 6, 8, etc. And odds would be 1, 3, 5. So looking at node C here, I can see I've got degree 2. So this is a degree 2, so that makes it an even node. B has 1, 2, 3, 4 degree, so fourth degree, that would make it even. A has just 1, and that would make it an odd node. D has 3, so that makes it an odd node. And E has 2, so that will make it an even node. And what I know is that because there's exactly 2 odd nodes, that I am going to have an Euler path, but not an Euler circuit. So if we were going to test that out, if I started at A, go to A to B to C, down to D, up to B, down to E, and back to D, with my start at A and my end at D. So I know that in this case I have an Euler path. So what we have here is that some bits that we want to make sure we remember for ourselves is this. If in your network you have only even nodes, so every single node in the network is even, for instance it's a degree 2 or 4 or 10, they don't all have to be 2, but you could have like a degree of 2, a degree of 6, a couple degree 4. As long as they're all even nodes, you'll have an Euler circuit, and you can start and finish, or you can start on any of the nodes and you'll finish back to that same one that you started on, but it doesn't matter where you start, you'll be able to complete the Euler circuit. Now if you only have 2 odd nodes, you'll have an Euler path, and it's only 2 odd nodes. If you have 1 odd, it's not going to work, you can't do it, it's not going to be an Euler path or an Euler circuit. If you have 3 odd nodes, you cannot do it, again it will not be an Euler path or a circuit. So it's exactly 2 odd nodes. So the other hint for us is that you will start and you will end on the odd nodes. So if you can identify your 2 odd nodes, it doesn't matter which one you start at, you'll finish at the other one. So keep that in mind. So if we take a look at an example here, classify each vertex and identify whether the graph is a path, a circuit, or neither. So if we think about what we were going to here, let's just identify even and odd nodes. So I notice A is 2, so that's even. Even. C has 3, oops, right, odd. D has 2, it will be even. E is 3 with odd, even, even, even. So what I know, because I have 2 odds exactly, I will have an Euler path, and I know that I can start on one of the odd nodes and I will finish on the other one. So if we give a go at this, if I start, label my start on O, trying to do an Euler path, so I'm tracing every single edge once without repeating any of the edges. You can see that I was able to complete an Euler path and that I finished on E. Now you could have started at E and finished on O, either way would be okay. So from here, just looking at applying this, I suggest for practice that you go ahead and find your Euler path or your Euler circuit through this network if there is one, but what they're wanting to get you at specifically here is just identifying how many even vertices. So for instance, I know A is even B is even, C is even, D is even, and E is even. We've got 2, 2, 4, 2, and 2. I have no odd vertices, so my classification is that this is going to be an Euler circuit. And my reason for that is all even nodes. Or you could have said no odd nodes. And again, your start or finish could be at any. So if I start at B, you can see I'll finish back at B again. So start / end. So again, it might be the case that one of these might not be, because you have, for instance, 1 or 3 or 5 or 7 odd nodes. So again, it's only exactly 2 odd nodes will give you an Euler circuit. And then do practice to see if you can find your path through all the way around the circuit, or the path.